Physical science time, we're talking about chemical reactions. First thing, let's define what a chemical reaction is in your own words. What's a chemical reaction?
A reaction between two things.
Yeah, we got a little dance party now. Reaction between two
chemicals.
Okay. Yeah, that's how we, like if we were in the habit of defining things by the words that they're made out of.
So if we were to dummy it down.
Yeah, if we were trying to tell a first grader, we might say it's a reaction between two chemicals. But let's try to define it without using the words that are there contained. Not necessarily just elements, because it could be compounds too, right? But two, what do we call it if it's either an element or a compound? No, not always. Substance, yeah. Two or more substances.
Combined.
No, they don't have to be even be two. One or more substances that change what they are, right? One or more substances. One or more substance. One or more substances which undergo a. Here's a letter check.
Hello. I think I'm in the wrong class.
Oh, okay. It was nice to have you here for a second, though. One or more substances which undergo a what? Yeah, we can't say chemical though, but a change in. You already said it once before, right? A change in composition. This is the definition of how a chemical reaction has occurred. Meaning that it changes what it's made out of, or changes the way it's made out. Let's use, as an example, let's use the one we had done in the lab. What was my one reactant in the lab?
Oh, but...
No,
Yeah.
it was, what was this?
Oh, hydrogen peroxide.
Hydrogen peroxide. And this, remember, we made it faster by using a catalyst, but the only reactant was hydrogen peroxide. What did it do?
Oh, it bubbled up. And
Yeah, it yields, but
But
what
it released... Oh,
verb did we use to describe how this changed?
It broke down.
Yes, and the fancier word for saying that exact same thing is?
Deteriorated.
It decomposed. Hydrogen peroxide decomposed into what other two things?
Oxygen and hydrogen.
No. Oxygen and?
CO2.
No?
Oh, H2O.
Yeah. Which is? Water. The initial substance was hydrogen peroxide,
Hold up.
which had certain properties, right? It looked like water, but it had properties other than water. What would happen if you drank it? You poison it. It's poisonous.
Yeah.
It has properties other than those of water. Remember, we had said this in the last lesson, in the last video. We had said in a chemical reaction, the things at the beginning are completely different from things at the end. We had sodium and chlorine, and they were completely different from sodium chloride. Remember, sodium was a silvery flammable metal. Chlorine was a green poisonous gas, and they make table salt, which is a little white powder. Right? In the same way, this has completely different properties from these. What are the properties of this?
Oxygen.
Yeah, what are the properties of it?
Gas.
It's a gas at room temperature. Blue. It is blue.
Not flammable.
Bluish.
Not flammable. Yeah, it has certain properties. Primarily as a gas, and then water is
Liquidy.
yeah, colorless, odorless, tasteless.
Now,
It's
salt water
different.
does have
It's different from hydrogen peroxide. Anyhow, this changed what it is. By definition, that's a chemical reaction. Chemical reaction involves a change in composition. These things are composed of different stuff than this is.
Mr. Cam, I have a question.
What is it, Wade?
So, with the hydrogen peroxide, you have O2, right?
Mhm.
So how's there already an O2, but then there's still an oxygen?
Yeah, exactly right. Because this equation is not fill in the blank. Balanced. This equation is not balanced. First, before we balance it, let's do just what we did on the bell work a second ago, and let's label it. What's this? Oh, that wasn't a good one.
Peroxide.
No, well, yeah, it is, but this is the reactant. In this case, it's a reactant. There's only one, and these two things are the
Products.
products, and we always have the reactants on the left and the products on the right. The left and right of what? Yield
that thing.
sign. And then we also have, in this case, just one, but we have a plus sign, which is used in the same way it is in math. Now, just like we did a second ago, we got to. Okay, so now we have to balance this. And why would we bother to balance a chemical equation? What's
stable?
That's why they bond. They bond to be stable. But we have to have it balanced because of what law?
Because the law of conservation.
The law of conservation of mass tells us that we have to have the same amount of stuff reacting as the stuff that is produced. The universe cannot create out of nothing all these different things. So we have on our reactant side altogether, we have 2 hydrogens and 2 oxygens. You can tell because the subscripts are 2 and 2. And then on the product side, we have how many oxygens altogether? 3.
3.
Thank you. And how many hydrogens? 2. So what could we do to balance this?
It's already balanced.
No, it isn't.
But you just said it was.
Multiply this oxygen by 2? Which oxygen do you mean? What can we do to balance the chemical equation? I just asked you this, but it wasn't on video. So that you remember for the future. What can we do to balance the chemical equation?
Are you feeling?
Yeah, we can multiply by coefficients. All we can do are put in whole number coefficients by which we multiply these things. Okay? So what's one thing we can do? What do we need to change, first of all?
Oxygen.
Oxygen. So how can we change the oxygen?
Multiply H2O by 2.
Multiply H2O by 2. Now we have altogether how many oxygens on this side?
4.
We have 4 oxygens on this side, because it's 2 plus 2 times 1 is 2. And then on this side we have how many?
2.
2. So we multiply that by 2, and that gives us 2 times 2 is 4 oxygens. 2 plus 2 times 1 is 4 oxygens. And then we have 4 hydrogens and 4 hydrogens. Is it balanced?
Yes.
Yes, it's
Yeah,
balanced. Okay, ask your question again, Kyler.
Do you call the numbers and letters an equation?
Yeah, do you call this an equation? Yes, this whole thing here is called a chemical equation. In the same way that we have math equations where one thing on the side on this side of the equal sign equals this thing on the other side of the equal sign, these must be equal. That's why it's called an equation. This process is called balancing a chemical equation. And we have to do it because it satisfies what, Haley? The law of conservation. We had already talked about what this kind of chemical equation is. What general kind of chemical reaction was this? You remember? Because it was hydrogen peroxide doing what?
Oh, decomposing.
Decomposing. So one of your vocab words, if you read through your vocab words, was the different types of chemical reaction. That's the thing we're going to talk about next. So I'm going to erase this. Does anyone need this still? Okay, I'm going to erase this. We're going to move on. So head the next thing, types of chemical reactions. Types of chemical reactions.
Combustion.
Okay, that's one of them, yep.
With the sodium, sodium metal with the water.
Type, let's spell it right. Types, this is going to take a long time. I'll make this kind of fancy. Oh, this is going to be hard for me.
Oh, you can do it.
I can do it. Oh, the hardest thing is it's going to probably run out of room. Don't remember.
Oh, don't write your C so big.
Yeah, you're right. Okay, I've also taken up the whole dang board here, but we abbreviate, luckily for me because I'm doing these bubble letters, we abbreviate the word reaction as RXN a lot of times. Types of chemical reactions. This abbreviation RXN stands for reaction.
Reaction.
Types of chemical reactions. Now that I've taken up 2/3 of the board with my heading, let's tell the types of chemical reactions. Let's put them in this order. Let's start with synthesis.
What's synthesis?
What's synthesis? Excellent question, Wade. Synthesis, photosynthesis is where light combines two things in a plant. Really, the plant combines two things in the presence of light. Synthesis means for two or more things to come together.
So,
like if you think about synthetic dye or synthetic flavoring, those are things that human beings have brought together. Synthesis means to create something new, and it specifically implies that something has been created. So synthesis, in this case, we use the general form. We're going to have, this can be like a little table. General form, and then we're going to have an example. I made it into a table. The general form is A plus B yields AB. A plus B yields AB. An example of this would be H2 plus O2 yields
O2.
H2O.
Oh, Jesus Christ.
Don't say that. Wait. Is this balanced? Let's balance it. So we have hydrogen gas, thing A, plus oxygen gas, thing B, yields water, which in this case is AB, thing A plus thing B.
So the yield sign is an equal sign.
The yield sign is an equal sign. The reason we use a yield sign instead of an equal sign is because equal implies they can go either direction, and sometimes that's the case in chemistry, and we use a different sign for that. But this, we use an arrow because these two things always come together to make this third thing and not the other way around. That's what this means. That's why we use an arrow. Anyway, let's balance this real quick. Where should I start?
Multiply H2O by 2.
Multiply H2O by 2.
And
That gives us
hydrogen by 2.
4 hydrogens. So multiply the 4. There we go. We have 2 O's, good. 4 H's and 4 H's, good. Okay. That's a synthesis reaction. That's a synthesis reaction.
Combustion.
I'm going to go in the same order as your book. The next one your book talks about is decomposition.
Like iron oxide?
No? Like what? We've already talked about one.
Manganese.
No?
Oh,
That was the
hydrogen
hydrogen
peroxide.
Hydrogen
is
peroxide.
one.
So in this case, if synthesis was A plus B yields AB, what do you think decomposition might be?
AB plus, or AB yields A plus B.
It's almost like the reverse of a synthesis reaction. In this case, we're just going to use the example we had a second ago because it was decomposition. H2O2 yields H2O plus O2. Once again, that wasn't balanced. We balanced it the same way that we balanced it before, and we get a balanced
What
decomposition
did you
reaction.
say the definition was?
The general form, Tyler? The general form was AB
No,
yields.
I got it. What's the definition of decomposition?
Well, synthesis was where two things come together to make a third different thing. This is where one thing breaks down into two different things. Whoop. Your book then talks about single displacement. Single displacement. This one, the example is kind of like, that's for double displacement. This is where we have, let's put it like this, AX plus B yields BX plus A. Some compound combines with some single thing to produce a different single thing in a different compound. An example of this would be silver chloride plus sodium yields sodium chloride plus silver. Think about it, the chlorine just kind of switched who it was with. We could get real deep into some metaphors about dating here, but let's don't. Pretend, let's just use one metaphor about dating because it works really well. The chlorine, pretend that's some dude and he's with his girlfriend, and there's this other,
Hot Jimmy.
Side chick.
there's another lady who he would rather be with, and then they switch, and now she's alone. The silver's one. But what's important about this is that, and this kind of gets yucky when we're talking about dating, but there's a list in your book. Look at page 643. Also, if you're watching this online and you don't have your book, you can just type into the Google, or any other search engines are available, so type into any search engine, type in activity series, listen to me please, type in activity series of metals or activity series of halogens, and you'll find on page 643 as one example, an activity series. Top right corner, you see that? An activity series in the top right corner of page 643. Everyone should be looking at it.
43?
Look, the most active metal on the activity series is what? Lithium is the most active. What's the least on this activity series? Gold. Anything, listen, and write this down. Looking at the activity series, anything higher will replace anything lower on the activity series. What's higher? Silver or sodium? Look at your activity series. Sodium is higher than silver. So what you do is you kind of put yourself in the shoes of the chlorine. You think, I'm chlorine. Would I rather be with silver, who I'm with now, or would I rather be with sodium? The answer is, based on the activity series, sodium, and so then you do switch. Nope, interrupt me. Then you do switch. If the thing you might be with is higher than the thing you're already with, then you do switch, always, all of the time. So once again, think of yourself as the chlorine. It's not always going to be
How
fun.
do you write this down without making it seem
Chlorine is gold.
You can make it weird. It's your
anything
notes.
higher will replace whatever?
So you think about it like this. Imagine this list is your own personal hotness list. You're like, oh yeah, check it out. Bill Clinton at the very top, right? And then all the way to the bottom, Johnny Depp. And you got all these like hundreds of dudes. I don't know your life, whatever. You got all these hundreds of people, and you're like, if I were with Johnny Depp, but Bill Clinton came along, I'm gonna switch. In the same way, if I'm chlorine, and I'm already with silver, and sodium comes along, I always will switch to be with sodium. Is that clear? Okay, so the analogy is weird, but does this make sense? Now, what if it were the other way around? What if instead it were sodium chloride plus silver? What's going to happen then? We write this. I'm going to put another example here. For instance, if we had, let's put lithium sulfate plus gold yields, which is higher, lithium or gold? Lithium. Wait, I'm already with lithium, so am I going to switch for the gold?
No.
No, so I write this.
Why would
No
you downgrade that?
RXN. Yeah, don't settle. That's the moral of the story.
Tell
Don't
me
settle.
that.
Don't downgrade. No RXN. What's RXN short for?
Reaction.
Reaction. This is kind of like an answer in math, which is no real numbers, or kind of like a place in the race at track that did not finish or no time. Lithium sulfate plus gold, no reaction. Nothing's going to happen. It's just going to be a lump of gold sitting in a solution of lithium sulfate.
Wait, one second. Can gold react with anything?
Yeah, with some things, but
Doesn't it like do the acid?
yeah, some acids will react with it. There are different circumstances, but listen. In a single displacement reaction, something higher is always preferable than something lower. And we sometimes also call this single replacement. I don't remember the phraseology I used on your test, but this is called either single displacement or single replacement. Either one is fine.
I think this one's my favorite.
The next one is called double displacement.
Oh, so you're replacing it with two people?
Not people. And this is in the form AX plus BY yields AY plus BX. So in this case, they've both already got partners, and they switch. And how do we tell if this is going to happen? We're going to talk about it in a second. But an example of this would be like lead 2 nitrate, plus potassium iodide yields potassium nitrate plus lead 2 iodide. You go over there for now. Bye. As a side note, is this balanced?
No.
Remember one of our little be quiet. Remember one of our little rules. One of our little rules about balancing was that if a polyatomic ion, like in this case nitrate, stays the same on both sides, we can just treat it like an element. So how many nitrates do I have on this side?
3.
No.
Oh, 1.
No. 2. I have 2 nitrates on this side. How many on this side? 1. 1. Nitrate. The 3 is part of it. Nitrate. So what can I multiply this by to make it 2?
Mister, can you keep your hand up for like 4 seconds?
Why?
Because I can't see.
Then, if this potassium now is 2, what do I have to do on the other side?
Multiply by 2.
Multiply by 2. So now we have 1 lead, 2 nitrates, 2 potassium, 2 potassium, 2 iodine, 2 iodine. So that is now balanced. So in this one it was fairly easy. How did we tell if a single displacement reaction would
That
occur?
was easy.
We used what?
Dating.
No, how did we tell if a single displacement reaction occurred? This one didn't, but this one did. How did we tell?
If it's active.
Exactly.
The activity series, right? The activity series. We use if the one it was going to replace was higher on the activity series. For the double displacement, there isn't one. A double displacement, write this down somewhere. A double displacement.
They swap.
Displacement, yeah, we already talked about that though. The double displacement reaction occurs if either product is insoluble or a gas or water. You know what water means.
H2O.
What- H2O. A gas. The book will tell you if it's a gas or not. Or what might this word insoluble mean?
Unable to dissolve.
Unable to dissolve. Unable to dissolve. What will happen is there's a picture on the bottom of 643 that shows this. On 643, there are two liquids that look clear. They both look like water, But when one clear liquid is poured into the other, a solid forms, because it's not soluble. That means that the double displacement reaction did occur. We'll do some examples of this in the lab and it'll make it a little bit clearer to you.
In the lab?
Not right now. And then the last type that your book talks about is oxidation reduction, which many other reactions fall into this category. Well, let's just only write a definition. An oxidation reduction reaction is one where electrons are transferred, and that's going to be satisfactory as a definition for right now. These get pretty involved, the oxidation reduction reaction, when you're in chemistry 2. But for now, it's satisfactory for you to know that oxidation and reduction occur when electrons are transferred from one thing to another. And they can be both. Like there are a lot of synthesis reactions are also oxidation reduction reactions. This one can be the other ones too. In fact, it is the other ones too. So there are 4 main types of reactions, and there's another category that many of them fall into. Do you have questions about the reaction types? We've got to talk about one more thing before we're done, but you have questions about the reaction types. The things you need to know about the reaction types are their names, the general form, and then be able to provide your own example that you can then balance. Okay? Questions before we move on?
No.
Does anyone still do this, or can I erase it?
No.
And you're good, thank you.
Okay, so now let's write down energy and chemical reactions. Energy and chemical reactions. These two words that we're going to use first are vocab words, and I just want you to define them for me. What's a catalyst?
Magnesium dioxide.
Okay, an example is manganese dioxide for some,
Speeds up a reaction.
but the definition, as Alexa and Wyatt have said, is that
That was Kyler, not Alexa.
okay, whatever. Is that it's some substance
That speeds
that speeds up a chemical reaction, but it doesn't get consumed. It's not a reactant, and it's not a product. It doesn't get consumed by the reaction. It just speeds it up. And then an inhibitor is the opposite.
It slows it
It
down.
slows down the chemical reaction. Yes.
So is that the reason why the magnesium
Manganese
dioxide was still at the bottom?
Yes, that's why the manganese dioxide was still at the bottom of your hydrogen peroxide, because it wasn't used up. It still was all there. 100%.
So how did that speed it up, but then it didn't do anything?
The other words that we need to, it just does. What it does, Wade, is on an atomic level, that manganese dioxide can latch onto the hydrogen peroxide, pull it apart, and then it detaches itself and goes on and does the same thing to the next one. Let's write down these things. There are 4 definitions more that we need. I'm going to have you define them. We're going to talk about exergonic, endergonic, exothermic, and endothermic. You have these definitions because you already wrote them in your vocab, so someone define, what does exergonic mean?
Let's take a look.
I'm going to start all of these with our sentence frame. A reaction that, blah, blah, blah. A reaction that, remember RXN stands for reaction. So an exergonic reaction is one that...
required to break original bonds.
Okay, fine, but that's not really a very succinct definition. You're right, there's more. Yeah, but what is it? This kind of reaction does what?
Saves them.
Does what to energy?
Saves it.
No. Releases.
Oh.
Releases energy. Endergonic then is probably what? A reaction that...
Holds in
uses
energy.
energy.
Yeah, and there's a better word for pulls in or uses.
Attracts.
Absorbs.
Absorbs.
You're welcome.
Exothermic, use your knowledge of Greek root words.
Thermic.
Releases heat.
Releases.
Whatever.
Blake gets so pressed about this.
Okay, and an endothermic one is one that
Enters the heat.
Sucks up
Absorbs heat.
Yeah.
exactly absorbs.
You understood.
Now,
yesterday.
listen. Can a reaction be exergonic and exothermic?
Yes.
Yes.
Sure it can. In fact, this is kind of like a square and rectangle situation. All exothermic reactions are also exergonic, but not all exergonic reactions are exothermic.
So is boiling water exothermic and
Boiling water is a physical change, not a chemical change.
It should be chemical.
Oh, it isn't though.
If you put salt in it, is it a chemical?
Not really. Kind of the process of salt dissolving is a chemical change. Anyway,
Hey, I can't see.
why? What other kinds of things could there be? What other kind of energy could there be besides heat?
Light.
Light. Yeah, some rarely, but some chemical reactions release light. No, I guess not rarely. They're like a glow stick is a chemical reaction that releases light.
What
It does
is-
release a
wait,
little bit of heat, so
wait,
it's technically both. What can you think of a endergonic chemical reaction that absorbs light?
solar panel.
Yeah.
No, okay, it enters the solar panel and then it goes into the battery. And the battery
Oh my
powers the
God.
light.
Did you say an egg?
Okay, what's
Those
another
little
example?
star things.
What's another example? A more common one that happens all around us. All the
Wait.
time.
Energy.
We absorb light.
Oh, photosynthesis.
Photosynthesis. Photosynthesis is also endergonic. It absorbs light energy. It doesn't have to be light. Some chemical reactions produce sound. Like if you think about the burning of black powder. Black powder, when you black powder.
Well, it's not a gun. It's what goes in it.
I'm done.
Bye.